Ever wondered if machines can actually think? Like really understand what they're doing?
It's a question that's been bugging philosophers and scientists for ages.
Well, today we're diving into one of the most famous thought experiments in artificial intelligence. The Chinese room?
Yeah, it's a real brain bender. Makes you think about what thinking even means.
We're pulling our info from the Wikipedia article on the Chinese room, so get ready for some mind-blowing stuff. Imagine this. You're in a room and you only speak English.
Okay, I'm picturing it.
And you've got this super detailed rule book, also in English. Someone starts slipping Chinese characters under the door.
Interesting.
And not just random characters, they're forming questions, instructions, even jokes. A whole conversation in written Chinese.
Like a secret code.
Exactly. And your job is to follow this rule book, match up the characters, rearrange them, then slip a new set back under the door, following the instructions perfectly.
Okay, I think I can handle that.
Here's the kicker, though. To the person outside, it seems like you're having a fluent conversation in Chinese.
Whoa, hold on. But
You don't understand a single word of it, right? You're just manipulating symbols based on rules, like a code cracker, not actually getting the meaning.
so you're saying I'm like a Chinese-speaking robot?
Kind of. And that is the heart of John Searle's argument. He's the philosopher who came up with this thought experiment. He's asking, can a computer, which basically just manipulates symbols, ever truly understand what it's processing?
Or is it all just one big elaborate show?
Exactly. We're talking about the difference between following rules and actually getting it. Like, I can follow a recipe and bake a cake,
Sure.
but I don't necessarily understand the chemistry of why the ingredients work together.
Ah, I see. So it's like I'm following the recipe of the Chinese language, but I don't actually taste the cake.
That's a great way to put it. Searle calls this difference syntax versus semantics. Syntax is like the grammar, the rules of the language.
Yeah.
Like you in the Chinese room, you're a master of Chinese syntax because of that rule book.
But semantics, that's all about the meaning, right? Like
Yeah.
actually tasting that cake.
You got it. And that's what Searle believes computers fundamentally lack, even if they use language in super complex ways, even if it sounds like they get you. He'd say it's all just syntax without the semantics.
So no matter how convincing the conversation seems,
Yeah.
it's all just smoke and mirrors.
Well, I don't know about that. Some might say, wait a minute, what about the whole system? You've got the person, the rule book, the characters all working together. Maybe the understanding comes from the whole setup, like a team effort.
That's a really interesting point, and it's a common counter-argument to the Chinese room. It's called the system reply.
The system reply. I like it. So like maybe I don't understand the Chinese on my own, but somehow the whole system gets it.
Exactly. But Searle had a pretty clever comeback for that, too.
Oh, let's hear it.
What if you memorize the entire rule book? Every rule, every character combination. You become a walking, talking Chinese room. Are you suddenly fluent in Chinese?
I see what you're getting at. Just because I know all the rules doesn't mean I actually understand what I'm saying. Right. And that was Searle's point. If even you, as the whole system, still don't truly understand, then true understanding can't just magically appear from making the system more complex.
So where does that leave us? If meaning isn't just baked into the symbols themselves, where does it come from?
It's like, how do we even know a tree is a tree and not just like some green blob?
Right. We learn to connect those symbols, the word tree, the image of a tree, to something in the real world.
So our experiences give those symbols meaning. Okay. What if we shake things up a bit? What if instead of a person in a room, it's a robot?
A robot.
Yeah, but not just any robot. This one has sensors. It can move around, interact with its environment. That's got to change things, right?
Ah, I see where you're going with this. That's getting at the robot reply, another counter-argument to the Chinese room.
The robot reply. Tell me more.
Well, some folks argue that if the system could learn through experience, like a child touching and tasting and figuring things out, then maybe real understanding could happen.
Okay, so it's not just blindly following rules anymore. It's actually out there in the world getting its hands dirty.
Exactly. It's not stuck in that room with just the symbols. It can connect those symbols to real live experiences.
This whole thing makes me wonder about the brain. Like, our brains are incredibly complex. What if, stay with me here, what if we could build a computer that perfectly mimicked the human brain? Neuron for neuron. Would that be enough for Searle? Would that count as understanding?
That's diving into some seriously deep waters. Searle actually addressed this,
He did.
Oh, yeah. And he wasn't just talking about the limits of the technology back then. His argument goes deeper, to the core of what a computer is.
Which
A
is?
symbol manipulator. Even if those symbols are super complex, even if they represent things like neurons firing, it's still, at its heart, manipulating symbols based on rules.
So you're saying even with a computer simulating billions of neurons, a whole network of them, it wouldn't be enough.
Searle called that the China brain. By the way, a whole nation of people, each acting like a neuron.
The China brain. Love it.
But yeah, even then, he'd argue it's still just going through the motions. It might look like understanding from the outside, but inside, it's a different story.
Man, this is bending my brain. It's like that thought experiment where if you replaced your brain cell by cell with tiny computers.
Ah, the classic brain replacement thought experiment. Always a mind bender.
At what point do you disappear?
Right. Searle would probably say that at no point would those silicon neurons suddenly become conscious. There's no magic moment where understanding pops into existence.
Wow. Okay, so this is all super fascinating, but I gotta ask. All these critiques of the Chinese room, they were from a while back. What about now? AI is light years ahead of where it was. Some of these programs are learning at insane speeds. Maybe raw computational power can bridge that gap.
That's the million-dollar question, isn't it? Has AI blown past the Chinese room argument?
Right. Like maybe Searle just couldn't imagine the kind of computing power we have today.
It's definitely a point of debate. Some people argue that he underestimated the power of sheer scale, that a brain-like system working at the speed and complexity of our minds, well, that might be something totally different.
Something we can't even comprehend yet.
Exactly. It's like trying to explain the internet to someone living in the Stone Age.
Mind-blowing. So, what's the verdict? Are our brains doing something fundamentally different? Or are we like those Stone Age folks scratching our heads at a smartphone? So are we like those Stone Age folks just completely missing the point?
Well, that's what some philosophers argue. The Churchlands, for example, they really went after Searle's argument.
They did?
Yeah, they said his whole line of thinking was limited by what he knew about computers back then.
Okay, interesting. What did they say?
Well, they used this really clever analogy. They said that expecting a computer to become conscious just by being complex enough, it's like thinking you could create light just by waving a magnet around really fast.
Because a magnet, no matter how much you wave it?
Exactly. It's not going to suddenly light up the room, right?
Yeah. Even though, technically, light is electromagnetic radiation.
Right. But our everyday experience tells us magnets and light, two different things.
Okay, I see what they're getting at.
The Churchlands said our intuitions about computers might be similarly limited. We're stuck in the magnets and light way of thinking.
So maybe we just can't even fathom what a truly advanced computer could do.
Exactly.
Okay. But even if that's true, even if a computer could act super intelligent, wouldn't Searle still say it doesn't have that inner experience?
You're hitting on a huge point there.
Like, it's not really feeling anything?
Right, it doesn't have that what it's like to be experience. Philosophers have a name for that problem. The problem of other minds.
Other minds.
Like, how do you know that I'm actually conscious? That I'm experiencing this conversation the way you are?
I mean, I guess I just take your word for it.
Exactly. We rely on behavior, communication, but Searle's argument makes you wonder, what if we're being fooled?
So you're saying even if an AI is writing poetry, composing symphonies,
maybe it's all just a very convincing performance, no one at home in the head, so to speak.
like a philosophical zombie?
There you go. Acting human, but with no inner world. Spooky, right?
Definitely creepy. But, this whole conversation, it really highlights what Searle was trying to do. He wasn't trying to limit AI, really.
He just wanted us to think.
Exactly. To ask ourselves, what do we actually mean when we say a machine thinks?
It's such a fundamental question, isn't it?
It really is. And who knows, maybe wrestling with these questions, it'll lead us to new breakthroughs, new ways of understanding the brain, new ways of building AI.
I'd say the Chinese room has given us plenty to think about, even all these years later.
It really has. And on that note, we're wrapping up another deep dive. Thanks for joining us, and until next time, keep those brain cells buzzing.